Outcome 3 says all electromagnetic waves travel at the same speed as light, i.e. 3 times 10 to the power 8 meters per second. So example 1, how long does it take Okay, so we deal with metric units in physics, so kilometres rather than miles. Now, when you first look at this question and think about what you're told in the question, right, your standard problem-solving technique, you've only got one number in there. And that needs to be converted into metres, remember? So that's all I can write down at first glance. But this is really what we're practicing in today's questions. You need to fill in what I had above there. That the speed, because this is identified this as a radio wave, the speed is 3 times 10 to the power 8 meters per second. So even if it doesn't specifically mention that in the question, you can fill that in. And your time is question mark. Now just watch, radio wave tends to trip a lot of people up, and a lot of people put in the speed of sound for radio waves because they can associate radio waves with sound. But radio waves carry sound information which your radio then turns into sound. But they're not actual sound waves, or else you'd be hearing Radio Clyde right now. Right, so Radio Clyde doesn't send out sound waves, it sends out radio waves which are part of the electromagnetic spectrum. So the formula which links these three numbers together is D equals VT. 556,000 equals 3 times 10 to the power 8 times T when we do our substitution. Right, remember SQA, you get a mark for formula, a mark for substitution. Then rearranging to get the final answer. Some of you might be able to do this in slightly less steps, but I'll just put in all the steps. Just swap sides, I've not changed anything there, but I've got T onto the left-hand side. But I want T on its own on the left-hand side, so I need to get rid of that 3 times 10 to the power 8. So I have to divide both sides by 3 times 10 to the power 8. Right, which will cancel out on the left-hand side and leave me T. And then I can get my calculator out and get the answer. So the answer in my calculator is 1.8533333. I'm going to round that off to 3 significant figures. So it's 1.85 times 10 to the minus 3 seconds. Right, example 2. So calculate the wavelengths of the waves emitted by Radio Clyde, which transmits at 102.5 megahertz. So remember we gave you the wee table of prefixes the other day? So here's an example where they're included. And once again, if I go through and list what I'm given in the question, it doesn't even actually mention in the question frequency. You've got to recognise that if it's given in hertz, that's frequency. And you've got to convert the mega part so that you've actually got it in hertz. But once again, that's the only number that I'm given, but I'm being asked to calculate a wavelength. So the only equation which links wavelength and frequency is V equals F lambda. So if you're going to solve this question, you're going to have to know what V is. So once again, that should hopefully be enough of a prompt to say, wait a minute, this is radio waves. Right? All radio waves are part of the electromagnetic spectrum. All parts of the electromagnetic spectrum travel at the same speed as light, which is 3 times 10 to the power 8. Now we've got enough information to solve the question. Substitute in again. 3 times 10 to the power 8 equals 102.5 times 10 to the 6 multiplied by lambda. So remember, always put in that substitution step. Right? I'm going to go with all the steps. Some of you might mathematically be able to go straight from the second line to the last line. I'm trying to get lambda on its own on the left-hand side, so that's why I swap sides first of all. And then I have to divide both sides by this 102.5 times 10 to the 6. That leaves me lambda, and then I get my calculator out once again. And rounding to 3 significant figures again, we get the wavelength of radial Clyde's waves.